Welcome to everyone. So today I am discussing that is numerical problem based on the frictions. Okay, so let's see the first numerical problem. So see here, the first numerical problems, it is written. So this diagram is given an inclined plane, as well as this is the horizontal smooth horizontal plane, and see this is what alpha, and see the friction is present to everywhere. So here the coefficient of friction is mu, in this surface the coefficient of friction is mu, because it is written. So in the particle, so W1 is equal to W2, it is given. Okay, and static friction is mu is same for all contiguous surfaces. Find the angle alpha. So you have to find this angle alpha. So how you can find out? So let's start with this. So if I consider, suppose this is the pulley, and see here the tension is T and here the tension is T. So let's start with the free body diagram for W1. So see, if I consider the W1 block, so this is the W1 block. Okay, so now vertically downward the weight, right, reaction will be, suppose R1 is the reaction, and see here the block want to move this direction. So friction will acting which direction? The friction will acting these directions. The frictional force, that is equal to mu into R1, right? So here I am writing that is mu into R1. This is the frictional force, and tension is acting this direction. So these are the forces on W1. So if I want to write the total forces along x direction, that is Fx is equal to 0, right? So T is acting this direction, mu R1 is acting negative, mu R1 is acting positive x-axis and T is acting negative x-axis. So I can write like this way. So mu R1 minus T is equal to 0. So T is equal to what? Mu into R1. So I can put it equation number 1. Okay, similar way for Fy is equal to 0 for this first block. This is W1 block. So see, along y axis positive direction R1 force is acting. So I am writing here R1, and negative direction W1. So I am writing plus R1 minus W1 is equal to 0. So similar way R1 is equal to your W1. This is your equation number 2. Okay, so now if I consider the block 2, so see, if I consider the block 2, I mean this is W2 block. So see here what I can write. So just I am copy the diagram. So see, this is the W2 block. So this is W2, right, and this direction capital T is the tension, and simply the block want to move this direction. So friction is acting which direction? So frictional force is acting these directions. So this is the frictional force. If I consider F2 is equal to mu R2, what is R2? This is the normal reaction by the surface, that is R2, right? So now if you see the diagram, this is alpha angle. So same way I can write here, this is alpha angle. So this angle is alpha. So now W2 is vertically downward. So see, now if I resolve this W2 into two components, if this angle is alpha, this angle must be alpha. So this is your W2 cos alpha, and this component is equal to W2 sin alpha, right? So next, so what is the net force along x-axis? So see this direction. So this is, I am considering the x directions, and this is I am considering the y directions, right? So see, So same way for the equilibrium of the forces, summation of total forces is equal to 0. So this direction total force is capital T and here mu r2 and this is W sine alpha. So I can write from this equation that is equal to T plus mu r2 minus W2 sine alpha is equal to 0, right? So that I can say here that is equal to T plus mu r2 minus W is equal to W2 sine alpha. Okay, so this equation I can write. Okay, so this is your equation number, this is equation number 1, 2, suppose this is your equation number 3. Okay, now next I am considering which things, that is equal to what, R2's total forces along y directions, summation of Fy is equal to what, 0. Okay, so that is equal to R2, okay, this is acting this direction and this one is equal to W2 cos alpha. So R2 minus W2 cos alpha is equal to 0. Okay, so that is equal to R2 is equal to W2 cos alpha. Okay, so this is your equation number 4. Now try to understand from 3 and 4 we are getting which things. So see, T plus mu R2 means what, W2 cos alpha, okay, is equal to W2 sine alpha. Okay, and see, T is equal to what, T is equal to your mu into R1. And see here, one line here I am writing, T is equal to mu into R1. So see, T is equal to mu into R1 I am writing plus mu into W2 cos alpha, okay, is equal to W2 sine alpha. Okay, so see, and R1 is equal to what, W1. Okay, so mu into W1 plus mu into W2 cos alpha is equal to W2 sine alpha. Okay, so if you can understood this one, now try to understand one thing, that is what, here one thing is given, that is W1 is equal to your W2. Okay, so W1 is equal to W2 if it is given. So see, I can write here, so this, all these forces will be cancelled, W1, W, because all are equal, because W1 and W2 both are equal, so I can cancel. So see, mu if you take comma, then it will be your what, 1 plus cos alpha is equal to sine alpha. Try to understand 1 plus cos alpha, that is equal to, from the trigonometry we know that this 1 plus cos alpha is equal to what, 2 into cos square alpha by 2, right? 2 into cos square alpha by 2 is equal to sine alpha means what, same way I can write 2 into sine alpha by 2 into cos alpha by 2. So if you can understood this one, so see, cos alpha by 2 and this one is cancelled, 2 is cancelled. So see, mu is equal to tan alpha by 2, right? Mu is equal to tan alpha by 2. So that is equal to what, alpha by 2 is equal to what, tan inverse mu. Alpha by 2 is equal to tan inverse mu, right? Tan inverse mu. So it is very simple. So alpha is equal to your 2 into tan inverse mu. Okay, so this is alpha value. Okay, understood?